Ever wondered how to optimize your network's bandwidth and provide link redundancy? EtherChannel could be your answer. Now, what exactly is EtherChannel? Simply put, it's a technology developed by Cisco that allows you to bundle multiple physical links between switches into a single logical link. Imagine having 4 lanes of traffic merging into one super lane. That's the power of EtherChannel. The benefits of using EtherChannel are twofold. First, it significantly enhances network performance by aggregating bandwidth from multiple connections, allowing data to flow more freely. Second, it provides link redundancy, ensuring that even if one link fails, the network still functions. EtherChannel is a key tool in the network engineer's kit, helping to streamline operations, boost productivity, and maintain network stability. It's an essential technology in modern networking, playing a significant role in everything from data centers to enterprise networks. Understanding EtherChannel is the first step to mastering its configuration and troubleshooting. Now that we know what EtherChannel is, we move on to how to configure it. Ready to dive in? EtherChannel is a fascinating technology that allows us to bundle several physical links to work as a single logical link, thereby increasing bandwidth and providing redundancy. Today, we will delve into the configuration of both Layer 2 and Layer 3 EtherChannel using the Link Aggregation Control Protocol, or LACP, as it's commonly known. Let's start with Layer 2 EtherChannel. The first step is to select the interfaces that you want to add to the EtherChannel group. Remember, these interfaces should have the same speed, duplex mode, and switch port mode. Once you've chosen the interfaces, the next step is to create the EtherChannel group. You can do this by using the command channel group, followed by the group number and the mode. The mode should be set to active to enable LACP. Now, moving on to Layer 3 EtherChannel. The process is quite similar to Layer 2 with a few notable differences. Here, instead of switch port mode, you have to make sure that the interfaces are in no switch port mode. After this, you create the EtherChannel group in the same way as before, using the channel group command. However, one more step is added in Layer 3 EtherChannel. You need to assign an IP address to the EtherChannel group. This is done by using the interface port channel command, followed by the group number and the IP address command. Once the EtherChannel group is created, the next step is to verify that the interfaces have been added to the group. This can be done by using the Show EtherChannel Summary command. This command will display the status of the EtherChannel group, the protocols used, and the member ports. Throughout the configuration process, it's important to pay attention to each step. Even a minor mistake can lead to EtherChannel not functioning as expected. For instance, if the interfaces have different speed or duplex mode, EtherChannel won't form. If the interfaces are not in the correct switch port mode, they won't be added to the EtherChannel group. And if the EtherChannel group is not assigned an IP address in Layer 3 EtherChannel, it won't be able to forward IP packets. The beauty of EtherChannel lies in its simplicity. While the technology behind it is complex, the configuration process is straightforward, provided you follow the steps carefully. It's a powerful tool that can significantly enhance the performance of your network by increasing bandwidth and providing redundancy. And there you have it, a configured EtherChannel. But it doesn't stop there. Configuration is done, but how do we know it's working as it should? Verification is the answer. So, let's delve into the process of verifying EtherChannel configuration. This is where the rubber meets the road, where we ascertain that our EtherChannel is functioning as expected. To start with, we use the Show EtherChannel Summary command. This command will pull up a summary of all configured EtherChannel interfaces. What we're looking for here are 2 key indicators. First, the flag P, which stands for In Port Channel, and indicates that the interface is part of an EtherChannel. Second, the flag U, which stands for In Use, and shows that the interface is operational. If you run the Show EtherChannel Summary command and see these flags, that's a good sign. Your EtherChannel is up and running. But we're not done yet. Next, we leverage the show interfaces trunk command. This command helps us verify that the Ether channel is allowing the correct VLAN traffic. The output should display the Ether channel interface and the allowed VLANs. If the VLANs you configured are listed, you're on the right track. Now, let's take it a step further with the show spanning tree command. This command is crucial for verifying that the spanning tree protocol views the Ether channel as a single link. The output should display the Ether channel interface as a designated port. If it does, you've hit the bullseye. Lastly, we utilize the show Ether channel port channel command. This command confirms that the protocol and load balance method are correctly configured. The output should match the protocol and load balancing method you set during configuration. And there you have it, the steps to verify your Ether channel configuration, each command revealing a piece of the puzzle, each output bringing clarity. Remember, verification isn't just a step in the process. It's a critical component of network management. It's the safety net that catches errors before they escalate into larger issues. Verification ensures that your Ether channel is up and running. But what if something goes wrong? Opening. No system is perfect and issues can arise. That's where troubleshooting comes in. As we delve into the realm of Ether channel troubleshooting, it's essential to remember that the key to solving any problem lies in understanding its root cause. With a firm grasp of the underlying principles, you can effectively navigate the complexities of Ether channel issues. One common issue you might encounter is Ether channel misconfiguration. This can occur when Ether channel is not configured correctly on all the interfaces in the bundle. A misconfiguration could result in intermittent connectivity or worse, a complete network blackout. To fix this, verify the Ether channel configuration on all interfaces and ensure uniformity. In some cases, you might face an Ether channel load balancing issue. Load balancing in Ether channel is crucial to evenly distribute traffic among the links in the bundle. If there's an imbalance, it can lead to overutilization of some links and underutilization of others, thereby affecting your network's efficiency. To troubleshoot this, check the load balancing method in use and adjust it as necessary to achieve a more balanced distribution of traffic. Another common issue is the inconsistent states problem. This happens when interfaces within an Ether channel bundle have inconsistent configurations, such as different switch port modes or VLANs. This inconsistency can cause the Ether channel to malfunction or the interfaces to be excluded from the bundle. The solution is to ensure consistency across all bundled interfaces in terms of switch port mode, allowed VLANs, and other configurations. You might also encounter problems related to Layer 2 and Layer 3 Ether channel. Layer 2 Ether channel can have issues if there's a loop in the network, often caused by a spanning tree protocol misconfiguration. Layer 3 Ether channel, on the other hand, can face issues with routing protocols. In both cases, you'll need to delve deeper into the respective layers' configurations and protocols to identify and resolve the issue. Lastly, let's talk about the Ether channel not forming issue. This can occur due to incompatible Ether channel modes on the interfaces. Remember, for an Ether channel to form, at least one end must be in the active or desirable mode. If both ends are passive or auto, the Ether channel won't form. The solution is to set the correct Ether channel mode on the interfaces. Troubleshooting is a methodical process. It requires patience, a keen eye for detail, and a solid understanding of Ether channel configurations. And while it might seem daunting at first with practice, it becomes second nature. Remember, in the world of networking, issues are not setbacks, but opportunities to learn and grow. Each problem you encounter and solve enhances your understanding of the system and makes you a better network engineer. Closing. Troubleshooting is an essential skill for any network engineer. It ensures that your network stays reliable and efficient. So, we've covered a lot today. Let's recap. We started by introducing EtherChannel, a technology that allows us to bundle multiple physical links into a single logical link for increased bandwidth and redundancy. We then dived into the nuts and bolts of configuring EtherChannel, whether it's Layer 2 or Layer 3 using Link Aggregation Control Protocol or LACP. We walked through the steps of how to configure it and also how to verify its configuration. We didn't stop there. We also discussed how to troubleshoot common EtherChannel issues. We explored different scenarios and solutions to help you navigate through potential roadblocks that you may encounter in your network engineering journey. In a nutshell, we've covered a whole gamut of EtherChannel, from its configuration to its troubleshooting. Mastering EtherChannel configuration and troubleshooting is an important part of network engineering. Thank you for tuning in to TechSpectrumPro. Remember, practice makes perfect. Until next time, keep exploring and learning.